Section 8.2b is about negative exponents. To begin, I would like you to pause the video and work your way through these questions using a calculator and trying to find or discover some relationships between exponents. You'll get the most out of this if you pause and try it on your own and then come back and see what the answers are. If you take a calculator and you plug in these values, you're going to get 2 to the 4th, which is 16, 8, 4, 2, 1, 1/2, 1/4, 1/8, and 1/16. And you're going to look at the relationship there, and you're going to try to see what you notice between 2 to the 4th and 2 to the negative 4th, and 2 to the 3rd, and 2 to the negative 3rd, and so on. Hopefully you realize that they're reciprocals of each other. That if you have a 2 to the positive 3rd and a 2 to the negative 3rd, one of them is 8 and the other is 1 over 8. So hopefully you recognize the reciprocals there. Then in question 3, if you make a conjecture about what 5 to the negative 1 is, that's going to be 1 over 5. You take the number 5 and you flip it and use the reciprocal. Question number 4, what's the value of 5 to the 0? When you plug that into your calculator, you get a 1. And then the last one, 0 to the 0, should give you an error. Here we're going to examine why the calculator gives you a 1 when you type something to the 0 power. And we're going to do that by looking at this fraction. 2 to the 4th power, well, that really means 2 times 2 times 2 times 2. And then down here, 2 to the 4th power means 2 times 2 times 2 times 2. Well, we know from fractions that we can cancel each one of these 2's. And we're left with a 1 on top, a 1 on the bottom, and so that equals 1. I also want to show you that based on the last video when we talked about the quotient of powers rule, that when you take bases that are the same and divide them, you subtract the exponents. So 4 minus 4 is 0. So from this, we can conclude that 2 to the 0 power also equals 1 because they both start from the same fraction. Now what we've just demonstrated is the 0 exponent rule. And that rule says if you take anything to the 0 power, you will always get a 1. Here we're going to demonstrate some 0 exponent problems. This one, I've seen a lot of people do this problem and just spend a lot of time doing work. But if you notice, this whole expression is inside parentheses and it's taken to the 0 power. And because of the 0 exponent rule that we just looked at, anything to the 0 power equals 1. So the answer to this problem is 1. That's it. Because you take the whole thing to the 0 power, it's a 1. So move on. Now contrast that to this problem where the 0 exponent only applies to the s. Over here it applies to the entire expression, but on the right it applies only to the s. So we end up with t to the 3rd over t times the number 1. So really this is just t to the 3rd over t. And when we divide bases with the same, or when we divide bases that are the same, we subtract the exponents. So t to the 3 minus 1 is t squared. Here we're going to demonstrate another property by looking at these two fractions. 8 to the 2nd is 8 times 8, and then 8 to the 5th is 8 times itself 5 times. Well, we know that we can cancel 8's here, leaving a 1 on the top, and 3 8's on the bottom becomes 8 to the 3rd on the bottom. So that's how you can simplify that fraction. Also, we know that when we divide bases that are the same, we subtract the exponents. 2 minus 5 is negative 3. So this also simplifies to x to the negative 3rd. So what we're saying is that x to the negative 3rd and 1 over x to the positive 3rd are the same thing. This leads us to our next property, which is the negative exponent property. And this property says this: when you have a base to a negative exponent, you can flip it and put it on the bottom of a fraction and make it positive. Likewise, when you have it on the bottom of a fraction and it's negative, you can flip it again and put it on the top of the fraction and make it positive. So because you cannot have negative exponents, you can always take that, flip it, put it on the bottom or the top of the fraction, depending on what's opposite, and it becomes a positive exponent. Here we have some examples with negative exponents. I'm going to simplify these. We have a b to the negative 3rd, and that's over 1 because there's no other b's to associate it with. We also have a c to the 2nd, which is over 1 because it's on the top. And we have a 1 over d to the negative 5th because that's on the bottom. I split them up like this so that we can deal with each one individually. So b to the negative third, how do we get rid of a negative? Well, the answer is we move it to the bottom or the top, depending on where it is now. So I'm going to move this b to the third to the bottom and make it positive. The c squared can stay on the top because it's positive, it's fine the way it is. And then over here, the d to the negative fifth has to move up and become a d to the positive fifth. Now putting all that together, we have c squared d to the fifth over b to the third. Now the reason I have to do that is because you cannot have negative exponents in your answers. We want to avoid all these negative exponents. So we use the negative exponent rule to flip things and make all the exponents positive. In this example, we have some more negative exponents. Let's start, however, with the negative 3 over 21. Those are numbers. Then we do the a to the negative fourth over a to the second. And then b to the seventh over b to the seventh. And 1 over c to the negative fifth. Just splitting that whole fraction up, and now we'll deal with each one separately. This negative here in front of the 3 is not a negative exponent. I don't want you to confuse this negative and this negative. They're not the same. They're not treated the same. One of them is an exponent. The other one's just a negative in front of a number. Well, in this case, 3 divided by 21 becomes a 1 over 7. It reduces, and it's still negative. So that just reduces as a normal fraction, negative 1 over 7. This one, when you divide bases that are the same, you subtract their exponents. So we have negative 1 over 7 times a to the negative sixth. So now we'll take that a to the negative sixth and we'll rewrite that as 1 over a to the positive sixth, because you can't have negative exponents, so we move it to the bottom and make it positive. Now for the b's, b to the seventh minus 7, it's going to give me a b to the 0, and as we've learned, anything to the 0 power is just a 1. And then over here, to move the c to the negative fifth, to make it positive, we're going to move it up and make it c to the positive fifth over 1. Now finishing this off, on the top we have a negative 1 with a c to the fifth, and on the bottom we have a 7a to the sixth. So you can see that breaking everything up into separate fractions and then dealing with them individually is often easier. But we've used our negative exponent rule and our zero exponent rule here to simplify.